Just north of the city of Tucson is the site of an important partnership between the University of Arizona, the Bureau of Reclamation, and several water companies and districts. And the focus of the work is on the salinity of water delivered by the Central Arizona Project.
It's not incredibly high salinity, but it's getting to us by the time it reaches Tucson at just about at the max you can use for potable use here. Tucson Water found the solution by recharging it and then blending it with groundwater. The way we're taking the salt out of the water is through the work of the chemical engineering folks. They're examining technologies to optimize the performance of reverse osmosis. Right now, standard ROs get about 80% recovery, industrial ROs. And what they'd like to do is get it up to about 95 to 98% recovery. I'm working on when that 20% comes off, what do you do with it? The typical way of disposing of industrial brines is to use an evaporation pond, a large lake system, and you pour it out there and just let the water evaporate. Well, for 5 million gallons a day, or whatever the order of magnitude is of that scale, it's something like 600 to 1,000 acres of surface area. We can't afford that kind of land. On the other hand, our experiments with the halophytes for using up the brine, we're seeing the capacity of the plants on the order of the same water use as an evaporative pond, or maybe a little better. So per unit area, we can use as much water using the plants, burn up, dispose of as much water with these salt-tolerant plants as an evaporative farm. And it'd be much more environmentally benign to grow something and sequester the salts in the soil somewhere than to have this large disposal area that has to be abandoned eventually, or whatever they have to do with it. So you get the RO processing the water, taking out as much as reasonably can be expected, and taking the remaining water, and instead of putting a whole lot of energy and squeezing more water out of it to get it down to some salty sludge, we would use that water to maybe generate some economic development. So instead of spending that extra $5 per 1,000 gallons to squeeze the water out, we can maybe get a few bucks per 1,000 gallons for use for some other economic development. I'm using a waste product to create some new production system.